2000, free response. Question number 6 is what we're going to do. Part B, no calculator allowed. So if I move question 6 up to the top, so we can see 6. It says consider the differential equation dy dx equals 3x squared over e to the 2y. There are only 2 parts, so again, this to me means you've got to be really careful. A lot of points here in just 2 parts. Find a solution y equals f of x to the differential equation satisfying the initial condition f of 0 equals half. Every time we have a dy dx in the AP, we have to separate variables. We have to get all the stuff with dy that's y's and all the stuff that's x with dx. And remember, if you think about the scoring we've done on some other of these, that is always, if you don't have that step, you can earn no points. So when you start from here, it doesn't matter how hard it is. It's probably worth 2 points that you multiply by e to the 2y dx on both sides. And you end up with e to the 2y dy equals 3x squared dx. You have to separate variables. And again, you might say to yourself, well, I knew that. I had to do that for the antiderivative. But it's so important. You've got to think to yourself, I know I got to do this step. I haven't looked yet, but I'm going to guess that's 2 points. All right? With only an A and B. This is a huge step. Now you're here. Now what do you do? Now you actually take the antiderivative. But this step is so critical, I want you to think of it as a separate thing. Well, taking the antiderivative of this is pretty easy. It's actually x cubed, isn't it? And I will put my plus c with the x. Get that there. Probably a point for the constant. Now we have to do the antiderivative of e to the 2y. Well, it's e to the 2y. Now we got to start thinking about what coefficient we need, right? So if we take the derivative of e to the 2y, we get e to the 2y times 2. So we're going to need a half here. Do you guys agree? Mm-hmm. All right. So there's the antiderivative. I hate fractions. You guys all agree? So what I'm going to do now, personally, is write this. And why I don't have to put a 2 on the c, do I? As long as when I calculate c, I don't put it back here with c1. I'll put c here. I might maybe label this one c1. I just know I want to find this constant right here. Okay? 2 times, So, how am I going to find c? Well, I have initial condition. We know when x is 0, what's y? 1/2. Let's plug that in. E to the 2 times a half plus 2 times 0 equals 2 times 0 plus c. So guess what? C is what? C is e to the 1, or c is e. All right. So there we go. We just found the constant. All right. And if you had the half, you'd get e over 2. But either way, you're going to get that. So now I'm going to plug this back into this equation right here. All right. So I'm going to group this so I can get some more room so we can see the problem as we work here. All right. So we've done all this work, and we now are really close. Okay. So I take e and I put it in. I have e to the 2y equals 2x cubed plus e. All right. So now if I look at the scoring sheet, I thought maybe this would be 6 or 7. It's 6 points. I'll level with you guys. We've earned 5 of them. So even if you struggle with the natural logs, we got to solve for y. That's going to be the last point, right? We don't have y equals yet. So how are we going to get rid of an e? We're going to have to take the ln of both sides, right? So if I take ln of e to the 2y equals ln, now be careful here, 2x cubed plus e, right? You got to do it as a whole thing. We call that from pre-calculus. All right? So we know the power will drop down now, so I can write 2y ln e. But what's ln e? 1. So now what all I got to do is solve for y, divide by 2. So I'll write y equals 1/2. I prefer coefficient personally. All right. It doesn't matter. You could write ln of 2x cubed plus e all over 2 would be right too. All right, and that would be your y. And if we're going to do points now, okay, so you kind of understand where it is. And I'll do that in what's called. I'll do it here and I'll do it purple. All right. There is a point for only one point for separating variables. Okay. There is 1 point for this derivative and 1 point for that derivative, and 1 point for the constant of integration. Okay. So there's 4 total. Uses initial condition. Not that you. All right. Not that you get the right answer. It says that you use it. All right. Finally, the last one is solving for y. All right, 6 points. Think about it. We even were explaining as we went, and we're only at 6 minutes on the tape. All right, so a really fast problem. So if you're looking at these, when you get this handout, the whole sheet, you want to probably pick 6 out first. You don't have to do it all the way. If B scares you, do A, go to another problem. I'm going to group this and get B queued up. All right, I would not expect Part B in a test nowadays, but find the range and domain of Part A. Realize when you have a log function, remember our logs, we know that I always think of it this way. If I have to think of my log, I'll think of e to the x first, right? And then I will think of reflecting that. And here is ln x. All right, what's the half do? The half just stretches it. Do you guys agree? Moves it up and down. But we know that when you have this value, you have to be a positive number. So a log has to have a positive number here. So find the range and domain. We know 2x cubed plus e has to be greater than 0. So now it just becomes solving this. Move e to the other side and divide by 2. You guys agree that's negative e over 2? And then take the cube root. So x is greater than the cube root of negative e over 2, which is allowable because it's a cube, right? So now we're going to have to write, what do we know about the domain here, all right? I think would start at, I think if you just leave it like this, so you could go domain is just x is greater than the cube root of negative e over 2. And the what would the range be? Doesn't matter. When you look at this curve right here.
All reals.
All reals. You say all reals or negative infinity to infinity. Yep. They give a point for doing the answer key. They give a point for knowing to do that, and then there's 1 point each for the domain and range. All right. And that is problem number 6 from 2000.